Today we're going to talk about how to analyze a quadratic function based upon a table. As you can see here, I have a table of values. It shows a quadratic function f of x equals ax squared plus bx plus c, whose axis symmetry is the line x equals 2. I can't seem to get this. And I'm going to use the information in the table to answer questions about my function. The first question is, what is the vertex? Well, since I know that the axis of symmetry is at x equals 2, I look for the point that has an x value of 2. So now I know that my vertex must be at 2, 4. Because the vertex is on the axis of symmetry. Then it asks me if the value of a is positive or negative. Well, now in order to decide that, I have to look at my y value at my vertex. The y value will either be a maximum or a minimum at that vertex point, and I can see that that is more than every other value in my y column. Therefore, my parabola or my function must open downwards because that is at a maximum. If you can imagine, your y value will hit a maximum value at the vertex when it opens down. So a must be negative. The y value at the vertex is a maximum. Therefore, it opens down. Okay. Now, the next question asks me to find the equation of my function in vertex form. Well, I know what my vertex is, and I know what vertex form looks like. That's y equals, and let's change the y. Let's make it f of x. That's f of x equals a times x minus h squared plus k. H comma k is my vertex, so I'm going to plug in what I know. X minus 4. Oops, wrong number. X minus 2. That's my h plus k, 4. Now I need to know my a value. In order to find my a value, I can really choose any other value, any other point from my table. I think I'll choose 3, 3 to find out what a is. But you'd get the same answer regardless of which point you choose. So when y is 3 when x is 3. So that means 3 has to equal 1 times a plus 4, or a is negative 1. So my function is negative times the quantity x minus 2 squared plus 4. So, and again, we expected a to be negative. You should always check that you're getting answers that line up with what you have reasoned to be true earlier. If it doesn't match, then you need to go back and check your work. Now it asks me to find the value of b. Well, I can multiply out f of x to find b. So f of x is negative the quantity x minus 2 squared. So that's x squared minus 4x plus 4. And that's plus 4 here. We'll distribute the negative. And then this becomes negative x squared plus 4x. So the value of b is 4. B is the value that's in front of the x. The last question is, what are the coordinates of the x-intercepts of the graph? Well, my function will cross the x-axis where y is 0. So I'm going to take my function f of x and set it equal to 0. So I'll factor out an x. Actually, I'm going to factor out a negative x. And then we'll set each factor equal to 0. So that means x is 0 or x minus 4 is 0. That would give me x is 4. So my x-intercepts, remember x-intercepts. So my first x-intercept would be at 0, 0. My next one would be at 4, 0. Ordered pairs. Okay, I'd like you to try this one on your own. When you're ready for the answer, press play. Okay, here are my answers. You'll notice my axis of symmetry was at the line x equals -3, so therefore my vertex was at -3, 1. I was asked if the value of a was positive or negative, and it's positive. You'll notice that a here, or you'll notice that my vertex, my y value is 1, and every other y value is more than that. So the y value is a minimum, and the parabola must open up. Then it asks for my equation in vertex form. So I wrote it out, putting in what I know. My vertex was at -3, so that's a minus a -3, and plus k, or 1. Then I plugged in another point to just see if I could solve for a. And what did I plug in? I plugged in -1, 3. So I could have chosen -2, 1.5, but I liked the whole number there. It was an easier problem with arithmetic to find my a value. So I plugged in -1, 3 and solved for a. I found a was a half, and then I rewrote my equation. So that is my equation in vertex form. To find b, I multiplied that out and simplified, and I found that y was equal to a half x squared plus 3x plus 11 halves, and therefore b must have been 3. Then I was asked to find the x-intercepts of my graph, so I set y equal to 0, and I solved, and I noticed that I got imaginary solutions, and since that's the case, there's no x-intercept. Another way I could have reasoned through that would have been this. If I know that my parabola is going to open up, and I know my vertex is at -3, 1, it's clear that there should be no x-intercepts. So I would like you to check your assignment online, finish that, and have a lovely day. I'll see you tomorrow.